Okay, let's talk about what is a relation, and then a function is a special type of relation, but let's first of all talk about what is a relation. A relation is a statement which shows a certain relationship between two values or variables. Or variables, usually x and y. Okay, so it's any relationship. The relationship can look like an equation. So you're used to some equations. Y equals 2x plus 1 is the equation of a line. Y equals x squared plus 1, which is the equation of a parabola. Or x squared plus y squared equals 25 is the equation of a circle. So you've seen equations before. So these are all examples of relations. Not all of these are functions though. Okay? This is a function, this is a function, this is not a function. And we'll get into that in a few minutes. Set of ordered pairs. Well, sometimes we don't have an equation, we just have a set of ordered pairs. So this might be an example, 0, 4. We could use something called arrow diagrams or mapping diagrams. I don't see them very often, but they pop up once in a while. So this might represent our domain. Domain is the word for our x values. Range is a word for our y values. So usually the range domain, the values are chosen arbitrarily. Try not to write on this line because we do need that line, right? This line here, I'll just have to jump over it or something. So for example, if an x value is -1, it could be mapped to 7. So the matching y value for the x value of -1 is 7. Just let me write that a little bit better. Okay, or we could have a value of 2 and that could map onto 8 and it could map onto 9. So this x value of 2 has two y values. So you'll see 2, 8 and 2, 9, etc., etc. Or it can be shown as a graph. So we could have, if this is our x-axis and that's our y-axis, we could have a parabola that looks something like that, right? So there's different ways to show relations and as well as functions. So a function is a special type, a function. And just to maybe help us out here, I'll write it in a different color so it doesn't interfere with the blue. But a function is, we'll have to skip over. Ooh, we'll go over there. A function is a special type of relation. Let's see if I can just change that. Special type of relation where each value in the domain has one and only corresponding value in the range. Has one and only one, they're emphasizing corresponding value in the domain. Okay, so a function is a special type of relation where each value in the, so in other words they're saying for every x value, there is only one y value. There is only one y value. Okay, it's a special type of relation where each value in the domain has one and only one corresponding value in the range. Thank you so much. In other words, for every x value, there is only one y value. So let's look at, there's different ways to represent functions in relations. So let's look at each scenario and see how we're going to determine whether it's a function or not. So if you're given a set of ordered pairs, ask yourself, does any x value repeat? If it does, if you have a 3 and a 5 and a 3 and a 2, for example, then it's not a function. Does any x value repeat? If an x value repeats, it is not a function. So if any x value repeats, it is not a function. So what about if we have arrow diagrams? Notice the value x value 2 has a y value of 1 as well as a y value of 8. So right away we know it's not a function. We ask ourselves, am I going too quickly? You're okay? Does any value in the first oval have more than one value in the second oval? If it does, it's not a function. If it does, it is not a function. So tell me, is this a function? No. We have two y values for one x value. Is this one a function? Right? X is never repeats, so yes, a function. That one's a function, not a function. What about graphs? For a graph, we do something called the vertical line test. Vertical line test. I'll call it VLT. So if I were to have a ruler, my rulers have gone missing. I don't know why. Here's one. If I were to have a ruler and if I were to draw a vertical line, will this vertical line ever hit the graph more than once? No. Okay. Does the line intersect the graph more than once? If it does, it is not a function. If it does, it is not a function. Okay, so in this case, yes, it is a function because every time we draw a vertical line, we only hit it once, So therefore, it is a function. Yes, it is a function. Now, for example, what if I were to have a circle? Is this circle a function? That's not a function. Circles are not functions. Are not functions, okay? Now, what if we have an equation? So what we can do is mentally substitute, or off to the side, various values for x and see if it has more than one resulting y value. If it does, it is not a function. Okay, so if I just, for example, sub x equals 2 into that equation, I get y equals 4 over 2 equals 2. Oh, I only get one value. Only. Oh, I'm so sorry. So we mentally substitute various values for x and see if it has more than one resulting y value. If it does, it is not a function. So when I sub in x equals 2, I get only one y value. Only one y value results. Therefore, it is a function. This is the reciprocal function, which you will learn. I have a feeling it's in the next lesson. I think, and let's see. Oh, I guess today's yeah, it's in this lesson here. So today's lesson is quite involved. You'll just have to hang in there. We're introducing a lot of things here. Okay, let's do some examples here. Notice when I put in x equals 25, say, what could y be? But y could be plus or minus 5, right? Don't forget plus or minus. So y equals plus or minus 5. So, is this a function? No, you get two y values for one x value, therefore not a function. Is this guy a function? So x equals 3 repeats, therefore not a function. Y equals x squared. Well, you can sub in x equals 5, y equals 25. One y value results, yes, a function. You want to know a shortcut? As soon as you see y squared, you know it's not a function. Right? As soon as you see a y squared or a y to the 4th or a y to the 6th, it's not a function. Okay, what about this one? You tell me, is this a function? right? It is no x value repeats, therefore not a function. Oh, yes, a function. Yes, a function. What about this? Yeah, vertical line test, right? Vertical line test, not a function. This is a straight line looking something like that. Is that a function? Right? If you put in any x value, you'll only get one y value. Yes, a function. Tell me this one, is this a function? Huh? No, because if you sub in x is 6, y can be positive root 6 or negative root 6, right? Not a function. Right? Because the points, if I put in a 4 for x, y could be 2, or if I put in a 4 for x, y could be negative 2, because it's plus or minus, so it's not a function. Is a circle a function? No. Because if you have 0, y could be 4. If x is 0, y could be negative 4. And is this? It passes the vertical line test, right? Therefore a function. Yes, a function. Yes, a function. Okay, let's look at domain and range. Okay, when we discuss x values and y values in a relation or a function, the x values make up what is known as the domain, and the y values make up what is known as the range. If you have a set of ordered pairs, domain is simply the first element, while range is the second element. So for example here, domain is 1, 3, 4, negative 1, 3. Range is 2, 6, 7, negative 2. For an arrow diagram, the domain is everything in the first oval, while range is everything in the second. For a graph, domain is the set of numbers included in the graph along the horizontal x-axis. Range is the set of numbers included in the graph that lay along the vertical y-axis. We'll do some examples. For an equation, domain is the set of all x values that x is allowed to be. Range is the set of all values for which y is allowed to be. And this is the proper notation, okay? You have to write it just like this. X such that negative 3 is less than or equal to x is less than 5. X is an element of real numbers. Y is similar. Y can be anything but 0. Y is an element of real numbers. Let's just do some practice. I don't know if we can do all the examples just because there is so much. We'll do as much as we can. I'll do maybe a few on each page, and then I have to start function notation. Let me look at the front here. I think this lesson is function notation. Oh, okay. Oh, thank goodness. Okay, thank goodness. This would have been a bit much. Okay, can you tell me the domain here? What is the domain in this example? Can anybody then tell me what domain is? Well, in this case, when it's a set of ordered pairs, we just have to list them. So this is -7, -4, -1, 0, 6. Right? We don't have to worry about, when it's like a set of ordered pairs, we just list them. So range here is, we just list all the y values. 1, 0, -1, 3, 2. Similarly here, there should be some brace brackets there. In this case, domain is 0, 1/2, 1, 5, 8. Range is -3, 0, 7. Oh, we don't list it twice. And then 7. Hold it. -3, 0, 7. We don't list them twice, so that's my bad. It's my mistake. And this is just a comma to separate them. So far, so good? Now, these are separate points, individual points, so we're just going to list them. Yes? Sorry, the range has what? Oh, you want to put it in order? Is that what he's saying? Okay, we can put it, if this is -1, we'll make that +1, and that a 2 and a 3. You want it in order? That helps the marker. A happy marker is an easy marker. Better? Okay. That makes my marking much more easier. But we just put it in order from lower value in the range to higher value. Okay, can you tell me the domain for this, assuming this is -1, -2, -4? The first one would be -4, right? That point corresponds to -4. This point is -2, -1, +1, 3, 4. And just let me check. -4, -2, right? We're reading these values for each dot. And now we're going to read the y values for each dot. So the lowest one is -3, right? This is -3 right there. This one is -2. This one is -1, 2, 3, and 5. Did everybody see how I got those numbers? Ah, this is different because we have a solid line. Tell me, now we're getting into proper set notation. It's x such that, what value can x be? Any real number. X, that's a R with the double stick there, whatever you want to call it. What about y? What can our range be? Y such that? Yeah, because that's about the y value there is, so it's 2 or lower. Y is less than or equal to 2. Y is an element of real numbers. Similarly here, x can be anything, because this goes forever in the domain. x such that x is an element of real numbers, and y has to be greater than or equal to -3, right? R, y such that y is greater than or equal to -3. So far, so good? Okay, tell me, what's our domain on this guy? X such that x is greater than or equal to -3. X is an element of real numbers. And what can y be? This stretches forever and ever, right? This stretches forever and ever. Y such that y is an element of real. Y can be anything. Okay. Tell me, what can x be? What is x in this one? Somebody, anybody? Greater than or equal to -2? What about range? So y is greater than or equal to? So far, so good? Let's do this guy. The x, y value, this point here is 4, 2, right? So domain is x such that x is less than or equal to 4, right? It's 4 or less. The graph goes this way. X is an element of real numbers. The range is y such that y is less than or equal to 2. Y is an element of real numbers. Could somebody stop the tapping? Thank you very much. Okay, notice this is an asymptote. An asymptote is a line the graph approaches but never touches. So see, it'll never touch this line. So x cannot be, right. So domain is x such that x cannot be 1, but it can be anything else. Now we have a horizontal asymptote here. It gets closer and closer to -1. So y such that y cannot be -1, y is an element of real numbers. Okay, it looks like this is -1.5. So we'll just say domain is x such that x cannot be -1.5, and R is y such that, what can y not equal? I want to give you a few more examples. Y equals root x minus 2. What can you tell me? Can we take the square root of a negative sign? Huh? So you know x minus 2 has to be greater than or equal to 0. X has to be greater than or equal to 2. So our domain on this function is x such that x is greater than or equal to 2. x is an element of real numbers. Now, if the lowest value x can be is -2, what's the lowest value y can be? Oh, sorry, the lowest value x can be is +2. What's the lowest value y can be? Sorry? Perfect. This always asks for the positive square root. So if x is 2, that square root is 0, y is 0. I want to do one more. We're going to draw a circle here as best as we can. It might be crooked. It's going to go up to 2, and it's going to go like this. Let's say that's -1, and that's 2. We'll put it up to 2. It's going to look something, okay, so it's a squished circle. Let's say that's my graph, okay? Kind of a circle that I stepped on. Can you tell me what my domain is? Sort of. So let's call it an oval. Can anyone tell me what my domain is? What's the lowest value of x? -1 is less than or equal to x is less than or equal to the highest value of x. So all this is saying x can be anything between -1 and 2. What about range? What's the lowest value y can be? And the biggest value? That's how you write it if you want to show it has a certain ending point and beginning point when it's between 2 points. May I answer any questions? Okay. Joe had us a summer job. Would you like to see your marks today? We can do it tomorrow or today. Or would you rather do word problems? Tomorrow is a shorter lesson. So why don't we do this tomorrow? And I'll show you. It is on the homework though.
Yeah, so let's do it now.
Get it over with? Why don't let's do one more example and I'll show you your mark, okay? We'll do one more example. We'll do these two tomorrow. Ready? Joe had a summer job that pays, he worked between 15 and 35 hours. His weekly salary is that. Describe the domain and range. What do you think? We'll say, so in this case, our domain variable is h, right? And our range variable is s. So what's our domain? Yeah, so I'm going to say our domain is h such that 15, he can work exactly 15 hours, right? Is less than or equal to h is less than or equal to 35. H is an element of real numbers because he can work 15 hours and 30 minutes, whatever. The range is, we're going to have to plug some numbers here. Range is S such that, what's 7 times 15? And what's 7 times 35? What did you get? 245. I'll take your word for it. And this we'll do these tomorrow. I'm going to show people who want to see their marks and